And I'm starting the recording now. So if you don't want to be recorded, make sure you don't unmute. I'll stop at the end to answer any questions. Yeah, and I'll stop the recording then. If you have any questions while I'm talking, feel free to unmute and just interrupt me. That's perfectly fine. I'm more than happy to answer questions as we go. So let's start. I'm going to quit this because I don't need it. Okay, here we go. Thank you everyone for joining. This is the first meetup for the newly founded Bergen Cloud User Group. My name is Karl-Mathias Moberg and I'm one of the founders. And we're doing an introduction to both the cloud today, for those that haven't used the cloud at all before, but also an introduction to Amazon Web Services. I'm going to do just a quick background on the user group first. It's an idea, and it's a user group that was the idea sparked this summer to create a user group more focused on the cloud and giving people an introduction to the cloud. Because I know that there are actually, just in Bergen alone, there's multiple other user groups that target different market segments and different people. We have the Amazon user group in itself. We have the Google developer group. Cloud Native has its own user group. And we also have another user group that's called Nerd School. All of these have very different, they're targeting different audiences. Both the Amazon, Google, and there's also an Azure one actually, are super interesting. They have a lot of very, very good content, a lot of very good speakers. But I know for myself, when I first joined the meetup scene about a year ago, a year and a half, even I, who had quite a bit of experience with most of this technology, it felt very high level. And yeah, if you're not familiar with the subject, I think it's very hard to get started in these different subjects. And I don't want to take away from that. I've spoken with a lot of these. I've spoken with the Amazon group, and the founder and the guy who runs the Cloud Native group is also a colleague of ours. So I didn't want to take that away because they're very useful to people that are already established in the industry. But it's kind of hard to get started, especially if you have no experience with the cloud. And that's what we're trying to do. Nerd School, if you haven't heard of them, is also a super interesting meetup group. They're a meetup group here in Bergen. They haven't been active now because of COVID, but their goal is to train programmers in the things they need to learn before they get started working that you don't learn at the universities. The universities in Norway specifically have been, unfortunately, pretty bad at adapting to more modern things. You learn very, very basic things, but you need so much more when you get started. And that's what Nerd School have been doing. I've spoken with them too, and I'm helping them out with some things. But they, when we talked about doing cloud things, they were more in they just wanted to focus on programming for now. So as a result, we have the Bergen Cloud User Group, where we're introducing it to more people. And the goal is to, yeah, like I said, introduce people to the cloud, give people an introduction to things, answer questions, and help people out. Because it can be frightening and a bit difficult to know where to begin. So we're trying out that. Everything I'm presenting today, all the materials and everything are available on GitHub. Everything is open source. You can use it for whatever you want. And I mean, everything from presentations to the workshop materials to the logos, everything is there. Do what you want with it. It's perfectly fine. So I'm going to briefly introduce myself as well. Like I said, my name is Karl-Mathias Moberg. I'm a cloud consultant at Tietoevry in Bergen. I've been specializing in AWS for some time. I've been working with it for about 4 years. I'm certified as a solutions architect and developer. And I'm also a part of the first cohort of AWS Educate Cloud Ambassadors that are targeting current students and people who have recently graduated from universities. So if you are a student and you're looking at the cloud, they're probably going to do recruiting in February, I think. If you are a student, I'd look at it if I were you. There's a lot of cool things you can get access to. I'm also a part-time, I do development, I'm a photographer, and as a small side note, I'm also a huge aviation geek. So if you were interested in airplanes, I know way too much about them. So that's me. We're gonna get started with some cloud computing basics. And what is cloud computing? I found this next image when I was doing this presentation, a similar presentation to this back in June. So I found this image at the start of COVID. This is not the cloud, I can tell you this, but the quote on Twitter was, "Due to less pollution, the files stored on the cloud are now clearly visible." And yeah, this is not it. But the cloud is, in fact, much of what we've been doing already. It is a bunch of servers, but it's someone else's computer. There is no cloud. It's just someone else's computer. So how did we get here? Well, we've gone from a world about 10 years ago, not even that probably, where companies had traditional server farms. You had a bunch of servers in racks in data centers somewhere. We had typically one server per service, meaning that if you had a SQL server, you had that running on one server, you had the website on another. If you had a CRM system, you had that on another physical box. You had a bunch of different physical servers, and although it worked, it was very inefficient. You had a lot of very low spec servers, typically just one processor and just a couple gigabytes of RAM, because you only did one thing. So you put a bunch of servers in, and it took a lot of space. It used a lot of power. It was not very effective. For most people, most businesses, you rarely had a CPU utilization that was anywhere near efficient. You had lower than 20% typically. And anytime you wanted to deploy something new, if you wanted a new application, you had to order a new server from a vendor. That took a couple weeks or months. Then you had to wait for operations to install it, which took a week or so. And the lead time for traditional servers are long. So it wasn't very effective. So for a while back, we moved to what many people are familiar with today, which are virtualized environments. They were great. Like, they were fantastic for what they did for quite a while. We had now, instead of a bunch of servers, each doing one specific thing, we now have fewer servers, but they're more utilized. You can run multiple virtual machines on one server. Great. You can now have better utilizations. You can now have CPU utilization that are much more up there in the 80%, 90%, and be comfortable with it because you know you're utilizing what you have. Again, the problem is anytime you need a new virtualization host, there's long lead times and the upfront costs are really high. Whereas a traditional server might have cost you $5,000, a good virtualization host probably costs you 10 times that. So the upfront costs are really high. So what is the future? What have we come to today? Well, we have what's known as the cloud, quote unquote. It's great. The cloud, the name the cloud and the phenomenon was pioneered by Salesforce, out of all people, or out of all companies. They introduced the concept of cloud in the very, very, very early 2000s. Amazon Web Services is the biggest current cloud vendor and the oldest. Amazon Web Services was first launched in 2002. It's been around for quite some time. And the Amazon Web Services in 2002 is not what you expect today. They didn't launch with virtualized servers or anything like we have today, but they launched with a bunch of messaging systems. If you've used AWS before and know some of the services, they launched with what's known as SQS, which is a messaging system. and simple notification service. It was really simple, but it launched in 2002 and it has grown since that. Most of the services you know today, virtualized storage and database and all these kinds of things, and servers in itself, were launched much later. We're talking 2005, 2006 for many of these. But the good thing about the cloud is that there's no upfront cost for most things. You can launch things in the cloud and not have to invest tens of thousands of dollars upfront. You pay as you go. And you also have near instant deployment. It isn't necessarily instant in a second, but it takes near instant. It's a couple minutes from when you hit deploy to when it's available. There's also a bunch of, with the cloud, you now have more services that are platform services where the cloud provider does a lot of the platform things for you, a lot of the infrastructure work for you. What does this mean again? Well, it means that you no longer have to worry about the infrastructure and the operating system. You can go to and you can focus only on the application that you're developing, which saves you time, saves you money, because you don't need an infrastructure team at the same level anymore. Yeah, it's a great starting point. And it's a managed service. The cloud services, you don't have to worry about power. You don't have to worry about internet. You don't have to worry about having an IT guy that's available 24/7 to make sure that if the power goes out in the data center, you need to have someone that can fix it. And there's one more thing that isn't talked too much about, and especially if you're getting started in cloud, a lot of people don't necessarily believe it. The security in the cloud it's just a simple fact. It's much better than a traditional on-prem server. I can almost guarantee you that if you were to go to or build your own data center and hire some of the best security people in Norway, you couldn't achieve the same level of security as AWS has in their data centers. Why? Because they can pay more. AWS pays people a lot of money, and they invest a lot of money in their data center security and their infrastructure security and online security. However, there's a caveat to this, and that is that it's only better at security if you follow their best practices. If you start going rogue and opening up security groups and not doing proper vetting of how traffic is flowing, it's not going to be better. You're going to have a bad time, but you save money because you don't have to worry about the physical security of the data center anymore, because someone else is doing it. So that's where we are now. But there's one key point to moving to the cloud, honestly, and that is, you can't just take what you have right now and move it to the cloud. That's going to generate a bill that's so big that your CEO is not going to be happy. Unfortunately, I know there are some companies, even in Norway, that does this. They take all their infrastructure, their existing virtual servers that they have in their data center, and just copies everything up to this cloud. It's a system known as lift and shift. And if you do it in a small scale for just a couple things, that's probably fine. But if you're moving your entire infrastructure that way, I guarantee you it's going to be more expensive, and your shareholders and board are not going to be happy. The cloud isn't built around moving just everything you have right now up there. You need to redesign the architecture slightly. You need to think a bit differently. And instead of just moving everything, you need to design a way that allows you to scale things. I have a good example of this. Don't take the numbers exactly literally, because the quote is a couple of years old. So they might have changed. But if you've heard of A Cloud Guru, they're one of the bigger and probably the biggest individual cloud training provider right now. They're specializing in cloud training. If you want to do AWS certifications, I can hardly recommend them. Their content is amazing. It's called, like I said, it's called A Cloud Guru. Their entire platform is built on AWS, and it's built using cloud native tools and solutions. They just a couple of weeks ago, they crossed 1 million members, if that's active or total members, I'm not sure, but either way, they have 1 million members. They serve a lot of content each month. It's built using serverless tools, and they have been quoted saying that their AWS bill is just a couple $100 or at least less than $1,000 per month. If they were to do that using traditional tools, so doing virtual machines in AWS, that bill would have been tens of thousands of dollars. It would be a lot more expensive. It requires a different architecture than what you're used to. But if you do it that way, the cloud is way cheaper. If you do it just the old way, it's a lot more expensive. So if you're thinking about moving all your work, make sure you check with someone that has experience. Get an architect in, and I guarantee you, you'll save that those consultancy hours in just a couple months of cloud bills for most people, or for most companies rather. So now, with that said, why do you want to move to the cloud? Well, there's 3 key points that all the cloud vendors talk about. The biggest ones are the elasticity and efficiency part of things. Elasticity means that you as a company can scale up and down or in and out as needed. It means that if you all of a sudden get a hug from Reddit, if your site ends up on the front page of Reddit and you get 1 million requests in a day, if your solution is built in the cloud, you'll automatically and dynamically scale to be able to handle that traffic. If you, on the other hand, have that in traditional infrastructure, you wouldn't be able to do that in most cases, unless you have really, really overbuilt your infrastructure. And in that case, you have too much money. Things like storage as well is also super important in the elasticity part here. You have in the cloud, you can have as much storage as you want, as long as you're willing to pay for it, and they provide it. Security as well, in the elasticity, you don't have to worry too much. In terms of efficiency, the fact that you can deploy an entire infrastructure in minutes to the cloud is a great step forward. Again, you don't have to wait months for the lead times for to get servers provisioned and ordered and racked. It's there. It's also pay as you go. Again, for most things, there are some exceptions to this, but in 90% of the case, it is pay as you go. You pay per second of instances you're running. And if you no longer need them, you terminate them, and you'll no longer pay for it. And finally, there's one for the C-level executives that the cloud vendors focus on, which is strategic value. It allows your team to focus on what they're supposed to do. If you're a developer and a company that develop applications, you can focus on doing that. You don't need an entire team, a data center team. You have someone that does that for you. You have someone that can regularly updates things, updates the servers, but also launches new features for you to use. And again, there's no upfront cost, you pay as you go. So typically CEOs are happy. For the final thing to also remember is that with cloud services, you can deploy globally an application again in minutes. You can launch a server in Sydney, in Europe, and in the US, literally in minutes, and distribute the load between them, so the people that are in Sydney will go to the Sydney server, etc. It's really efficient. You can do it in minutes, and again, if you're doing this on-prem, you can't. You would need to send someone out to do it, and it's a pain. So that's why. Now, I'm going to briefly touch on a couple of the acronyms that are very common in cloud services. If most of you probably have heard of these, but if you haven't, it's a quick introduction, and there's a lot of them, but I'm just going to mention a couple. If the first one is IaaS, so it's infrastructure as a service. This is the basic cloud vendors such as AWS or Azure, Google Cloud, providing you a virtual machine. When you get the infrastructure as a service, that means that someone is responsible for doing the networking between the server and the internet. Someone is responsible for the physical servers, etc., power, all these things. They're providing the backend infrastructure you're doing the rest. You're installing the or not installing the operating system, sorry. You're patching the operating system, installing the software you need. You're doing all the other things, but the cloud vendor provides you with the infrastructure. The next step to this is what's known as platform as a service, and this is more in the things when people might not necessarily have heard about. In the terms of platform as a service, in these cases, the cloud vendor also provides and manages the operating system for the service. So you no longer have to worry about the backend server updating it, etc. Examples here are managed databases are a good example. Amazon has what's known as RDS. Azure has their managed SQL servers. Again, you don't worry about the backend things. The server is managed for you, and you only focus on the SQL server itself and what's the content inside of it. Finally, we have software as a service, and this is where the entire piece of software is delivered to you. You don't worry about anything. Office 365, Google Suite, Salesforce, what else? Slack is a software as a service. Another good example also is in Azure. Azure AD is a software as a service, or can be defined as software as a service. You no longer have to worry about the backend infrastructure of Active Directory. You don't have to spin up a domain controller, etc. Microsoft is doing everything for you. And trust me, this is just the first three. There's a ton more. You can probably just put your name in there as a service. Backup as a service is definitely a thing, and a lot more. So if you say AAS, it's probably something as a service, and Google is your friend if you don't know it. All right. The final thing I'm going to touch on is the different types of deployment of cloud infrastructure deployment in general. And you'll see these too. There's what's known as the private cloud. This is the traditional network or the traditional infrastructure where you have physical servers on-prem somewhere, and all your clients and all your users connect either through the internet. They might connect to those servers, or they might employees might connect to them over VPN or using your internal network, something like that. The point is that the servers are on-prem, you're managing them. It's what's known as the private cloud. The long deployment times and everything that we've talked about. There's also something known as the hybrid cloud, and this is fairly common these days. This is where your company is using a combination of both the cloud and on-prem. You might have some applications that run on-prem. You might have Active Directory, for example, running on the domain controller on your location, but you might connect it to Office 365 and use Exchange Online and use the AD connector to synchronize things between on-prem and cloud. You might have some applications that are deployed to the cloud, or you might have other solutions like this, and some could be on-prem still. And then finally, you have the public cloud. That's what Amazon is. You can build a hybrid cloud with Amazon, no problem. But if you are in the public cloud, you're typically only in Amazon's world, or Azure or Google Cloud. This is perfect for startups. If you're a new company these days, I wouldn't invest a lot of money in upfront costs for infrastructure. If you're a new company, just go for the build it for the cloud to begin with. You'll save yourself upfront costs, and yeah, you'll be up for you'll be going with the flow. You're gonna get all the elasticity and stuff that comes with the cloud. It also comes with the fact that you now can scale easily. Now, we're gonna start talking about Amazon, because Amazon is by far the largest cloud provider. There are a bunch out here. Amazon is the biggest. Azure and Google Cloud are number 2. There's also a bunch of others, and I only included 4 of them. Oracle and IBM you might have heard of. They both have their own cloud services. DigitalOcean you might have heard of as well. It's not that big. However, and especially if you're a big company, you're probably not using DigitalOcean. But if you're a small company that want to utilize a lot of the elasticity tools, DigitalOcean is probably your best bet, to be honest. You can spin up servers and services in DigitalOcean for $5 a month and have a fantastic service. If you want more advanced features, they're not there. They don't offer them, but they have a bunch of the basic virtual machines in the cloud. They're amazing. I use them for a lot of personal projects and stuff. Another one that I included here because they're not necessarily well known in Europe, but they're becoming big, is Alibaba Cloud. Alibaba is the Amazon equivalent in China, and in China, Alibaba is gigantic. If you've heard of AliExpress, AliExpress is a sub-company of Alibaba. They're making so much money, it's hard to count. And they've launched their own cloud service as well. It's beginning to be very big in China, but they're also expanding. I actually saw the other day, I saw someone complete multiple certifications take the multiple certifications for the Alibaba Cloud in Europe, because they're becoming much bigger than you would expect. There are questions because they're a Chinese company and servers in China, but yeah, take it for what you want. But like I said, Amazon is the biggest, and they're the biggest by far. They have 32.4% of the market share in Q4 2019. That might not necessarily sound that big when you're just hearing 32%, cool. But when you take Google and Azure combined, if you take their market share combined, it's 23%. If you take Google, Azure, and Alibaba to combine, you're at 29. So they're big, they're gigantic. They're making $10 billion per quarter in Q4, which is significantly more than anyone else. And on the other hand, though, both Google and Azure are growing like crazy. They have an annual growth of 60%, so they're gigantic, those two. That's not saying that Amazon is necessarily slowing down. They're growing by 30% too, but yeah. The Azure is capturing some of the market share, but right now, globally, Amazon is gigantic. And the reason why this is, or not necessarily the reason why, but the way they've done this is that they were, again, the first vendor to do this, and a lot of people have stuck with them. Now, we're going to talk about how Amazon is, or the Amazon Web Services are organized. Amazon Web Services have data centers across the world, and they're spread out over what's known as regions. Each blue dot on the map here is a region, and each individual blue dot or each region consists of multiple data centers. For example, there's a blue dot in Stockholm, as you can see. That's the one of the AWS regions. That region consists of 3 individual data centers. The data centers are known as known as availability zones, and each region has at least 2 or maybe 3. I think they're all at 3 at this point. But some of them have even more. Each individual availability zone are physically spread out. So each data center are physically pretty far apart, but they're all within 100 kilometers of each other. And they're interconnected with very high-speed fibers. So in theory, you could deploy a SQL server to one availability zone and deploy the web front end to another. And you wouldn't, in most cases, notice the lag between the two because the speed is fairly decent here. So there wouldn't be much delay. In reality, you wouldn't do that. You would, in most cases, deploy both one web server and a SQL server to both availability zones to achieve high availability, but that's a more advanced topic, so we're not going to spend too much time on that. But it allows for it, and that's why it's there. The reason why they have multiple is that's so that one data center can fail and the region is still available. Each availability zone has multiple redundant connections, both of internet and power. They have multiple power lines in and internet lines in, so that in case some farmer decides that their tractor is going to ruin a fiber today, the entire data center doesn't go down. They have, again, redundancy here. The orange dots on this map are new zones that are coming soon. I think there has been a couple more announced since this photo. And I think they're opened at least one more in South Africa. It isn't that relevant to us though. In addition to each of these availability zones, Amazon also has a CDN network that allows you to cache things such as videos or static objects or things that you might want to speed up. These edge locations for their CDN are in much more places. We have multiple in Norway. I think we have at least one in Oslo, and I think we have one on the West Coast as well. Meaning that if you're trying to ping a lot of things that are connected to what's the CDN network known as CloudFront, the delay is very, very good even in Norway. And you can have, like, I think the delay to the one in Oslo is just 5 or 6 milliseconds from Bergen. It's really, really good. And it's a way for you to distribute things using a CDN and speed up things significantly. So that's the region. That's how the physical things are working. I'm going to quickly introduce some AWS services to you all. There are a lot of them. There's a nice YouTube video that someone sent me the other day. There was a guy that made a song with every single product name of every AWS service. There was 170 something services. The video is 4 weeks old, 3 or 4 weeks old, and it's already outdated. They have added 10 more services since that video was made. So there's 180-ish services, with everything ranging from virtual machines, like we've talked about, to they offer tools for creating user pools and managing your app users, to VPN services and database and all kinds of things. But I'm going to, again, briefly touch on a couple. This is what's known as EC2. We have S3. We have AWS Lambda, which we're going to talk a bit about, Elastic Cache, and a whole bunch of others. We're going to focus on 4 of them in this presentation first. I'm also going to be available if you guys want to complete the workshop part that I've designed after this. I'd be happy to help out. We're only going to focus on a couple of things today, and we can move on and do a bunch more of these in depth at a later point. But what's probably what Amazon is probably most known for is S3. It's their what's known as Amazon S3, or Simple Storage Service. And yes, S3 means Simple Storage Service. There has never been an S1 or S2. Amazon, unfortunately, I'm not too happy with their naming of things, but it can be confusing at times. S3 is what's known as object storage. Object storage means that you can put files there, you can put images or documents or zip files or something. You can put objects there. It's not a way for you to install an operating system. You put files in what's known as buckets, and they technically have a flat structure, but you can create folders and organize things how you want. It's truly unlimited storage, and when they say unlimited, they mean unlimited storage. You can have the maximum, however, file size per file is only 5 terabytes only. But if you have petabytes of data, which some customers in AWS have, there are a lot of satellite companies and a lot of oil companies that do a lot of geo data. We're talking petabytes upon petabytes of data. This data can be sent to Amazon and they will store it for you. And they truly have unlimited. And one Amazon executive I met at a conference once described it this way and said that you can drive a truck full of hard drives to them if you want to. You can do that, and it's probably a lot faster than doing it over the internet. If you have multiple petabytes of data, fill up a truck, drive it to their data center, and they guarantee that you will never be able to hand them the hard drives faster than they can get hard drives in the back door and increase the S3 storage that you have. It's truly unlimited. Amazon also offers tools for this. It's really cool. If you've ever heard of it, look up Amazon Snowball and their snow line. They have a literal semi truck that you can order with a fiber connection in the back that you plug into your data center, and they transfer things to the semi truck and they drive it to S3. It's really cool. S3 has what's known as 11 nines of durability. What this means in practice is that the chance of you losing any data that's stored in S3 is as close to zero as humanly possible. I think the chances is 1 in a million years or 1 in a 10 million years, something like that. So the chances of, if you upload things to if you upload things to S3, the chances of you losing that data is basically zero. S3 consists of 3 storage classes. That's 3 different pricing models, basically, of how you can store data. The standard class is standard. You pay a certain amount. But if you want to save some money, especially if you have large data sets, if you're talking petabytes of data, it can get quite expensive quite fast. So you can store data in what's known as infrequent access. Infrequent access, then it's instead of potentially being placed on SSD drives to have it quickly available for you, infrequent access might be stored on mechanical drives. They might be stored with, there are some options you can choose to get less durability. So the chance of theoretically losing data is higher, limiting it to 1 availability zones, things like this, to save you money if you want to. You don't have to, but you can save money that way. There's also a final tier known as Glacier. This is permanent, or not necessarily permanent. This is for archival stuff. If you have financial records, you are required by law to save, for example, but you don't need to access it. If you need to access it, you might have a good amount of time, or you don't need to access it often. It's stored on tape, and it's stored in a permanent vault, so that the recovery time when you want to access the data is measured in hours. So when you do a request saying, oh, I want to access this piece of data, it's going to take you 1 to 3 hours to get it. It's meant for you as a final backup in case your building burns down, in case someone steals a laptop full of important documents, something like this. It's disaster recovery. It's super cheap to store data in Glacier. But again, it takes a while to recover data. You can choose to replicate the data both within one region. So it's split between availability zones, but you can also do cross-region replication if you want to do extra durability. Or you can use it to speed up traffic. If you want to speed up the download, for example, for someone that's in the US and you're normally hosting out of Sydney, you can do that. You can replicate it to a US site. One final thing to note is that you can actually host websites directly out of S3. You don't need a virtual machine or anything else. If you have a website that just runs if it's a static site, basically, if it's running JavaScript and it doesn't require any scripting languages on the back end, you can host both the images and the HTML files and run it directly out of S3. It's really simple. It's super cheap. If you, again, just want to host a static front page for something, you can do it in S3. That's S3. It's super nice. I've started utilizing it for a couple of personal projects actually, and yeah, it's really efficient and really easy to work with. And for professional projects, it's a dream. Now, we're gonna, the next thing is EC2. Again, there's never been an EC1. This is Amazon calling it the Elastic Compute Cloud, so EC2. This is virtual machines. This is like you would spin up a server in VMware. You can do it in Amazon in EC2. Each virtual machine is not replicated anywhere, meaning that if you deploy a virtual machine, it's placed in one availability zone. You pick which one you want. It's up to you, but it's by default, it's set to one availability zone. You can spin up and do replication and things like this. But if you want to replicate it across availability zones, you need to get a load balancer to deal with it. And you need to spin up 2 instances. So you're going to pay for 2 instances to do so. EC2, through its elasticity model, allows you to scale both vertically, so you can add more CPU or RAM or whatever you need. Or the most common way to do things is scale horizontally. What horizontal scaling means, for those of you haven't done it before, is that you add more instances to your workload. This means that if you start with 1 instance and you realize, oh crap, this instance is running at 90% CPU, you can add another one. And using load balancing tools that are built into EC2, EC2 can dynamically load balance the traffic between the 2 servers for you. Auto scaling is also, like I said, a built-in tool of EC2. You can set your own parameters. You decide how you want to scale. You can set if you want to scale using CPU limits or memory limits or disk read or write limits. It's up to you how you want to scale. And Amazon will automatically add more instances as you need them. When EC2 recognizes that the traffic load has died down and the instances are running at low capacity or with very limited usage again, it will scale down. And that's one of the bigger things that Amazon are pushing, that they don't want you to pay too much for what you're using. They don't want to charge you more. So they try to make things cheaper for you. Like EC or like S3, there's different pricing models for EC2. The normal one, the one that you most likely will use, and the one if you're participating in the workshop afterwards, the most common instance type is what's known as on-demand. In on-demand instances, you pay from the second you start the instance to when you terminate them. There's no contracts, nothing. You pay per second. But if you have a workload that you know you're going to keep having for the next year or the next 3 years, you can do a contract with Amazon and do what's known as a reserved instance. And by doing so, you're reserving capacity. You're reserving computer capacity, saying that, okay, I need 2 or 3 or 30 servers with this amount of CPU and this amount of RAM. And you can do 1 or 3 year contracts with them. Just doing that upfront, just reserving that will save you a significant amount of money. I think it's 40 or 50% on-demand instances. However, if you're willing to pay for some of this upfront, if you're willing to pay for about 50% upfront, you'll significantly up the rebate. And if you're willing to pay for it all upfront, you'll save up to 75% off the on-demand instances. So if you have a company that you know you're going to need this amount of compute capacity for whatever reason for a year, it's well worth doing reserved instances because you're going to save yourself a lot of money. There's also one more price model that is not necessarily, it's not going to work for everyone, but for workloads that are not time sensitive, for workloads that can be interrupted for whatever reason. We're talking typically research jobs and things like this. Not necessarily web servers. I know for a fact that people have run web servers on what's known as spot instances. And I know that's the way you can get the most amount of rebate out of Amazon. The problem or the thing with the spot instances is that you set a price per hour and you bid on the instances. You set that I'm willing to pay, let's say $1 per hour per instance. And if the price drops below that $1 per hour, you will get access to the instances and Amazon will start running the workload for you. As soon as the bid price goes above $1, you'll get either a 2 or 5 minute warning. I can't remember. I think it's 2 or 5 minute warning saying that, okay, the price is above $1 now. We are going to terminate this instance in 2 or 5 minutes, something like that. This requires that your data isn't stored on the server. You need some sort of way to store the work you're doing, either in a managed database or you can store it in S3 or something like this. So it's typically done for research or non-time sensitive workloads. They're using what's known as AMIs. You'll see that when you spin up an instance, you will get a bunch of different AMI options. These are Amazon machine images. They're basically just like VMware images, an operating system with a set of tools installed. You can pick from a ton of them. Amazon provides hundreds. There are different options. There's also an Amazon marketplace where you yourself can create an instance and you can sell it to people. It's typically done by companies such as Cisco is a big one. They sell a lot of security software that you can spin up in EC2. You can do virtual routers and VPN connections and things like this. And then you can charge people per hour. That comes on top of the normal EC2 pricing. For most things, you're just going to use the default images for things. Those are, it will say whatever, but the most common one is Ubuntu and Amazon Linux. Amazon Linux is a Red Hat derivative. So if you've used Red Hat or CentOS, Amazon Linux is a good alternative. That's virtual machines. The next thing I'm going to talk about is I've noted Amazon Aurora because Aurora is very cool. But this is equivalent to what we're going to talk about next meetup, which is databases and what's known as RDS. But Amazon Aurora is a managed database, or it's a managed relational database rather. It's compatible with both MySQL and PostgreSQL, but it's much faster than MySQL. And what's really cool about it is that it's redundant by default. And there's no read or write delay. If you've ever dealt with MySQL read replicas, you know that there, in most cases, is a slight delay when data is replicated across the read replicas. With Amazon Aurora, that delay is almost zero. It's built in a very interesting way, and if you're interested in this, I highly recommend looking it up. Just looking up Amazon Aurora, it's really cool. By default, when you spin it up, it will replicate across 3 availability zones. And if you need more read replicas, you can have up to 15 of them. It's a fully managed relational database. You don't have to worry about the infrastructure. Amazon does everything for you. And you only insert the SQL things that you need to do in the normal SQL database. However, the reason why we're not using it in the workshop next time is because it's fairly expensive and there's no free tier. So there's no way to test it out without being charged quite a bit for it. But if you're doing SQL in production, I'd highly recommend looking at Aurora because it's really cool. If you need something other than MySQL or PostgreSQL, if you need Oracle for whatever reason, or if you need Microsoft SQL, that's also available, not in Aurora, but what's known as Amazon RDS, which is the relational database service that they have. They have a bunch of different ones there, MariaDB, and a bunch of them. Now, the final thing I'm gonna mention today is AWS Lambda. Lambda is really cool, and it's what's powering the A Cloud Guru service that I mentioned earlier. If I was a betting man and was to predict something, I would say that Lambda and these kinds of things is where we're moving to. We're moving away from having to worry about servers and moving to Lambda, which is a way for you to run code without worrying about a server at all. Using Amazon or AWS Lambda, you can write code in Java or Go, PowerShell, Python, Node.js, and Ruby. I think there's a couple more actually now, but those are the default and big languages that you can write functions here and have them execute without you worrying about any servers. It's really cool. You pay, instead of paying for a server that runs that has idle time, you only pay every time a function executes, and you pay for the compute time. So the amount of time it's spent to run the function you've designed. It's infinitely scalable in theory. So no matter how, if your site is built on this, like I said, a Cloud Guru is built on this. And if yours is built on it, it can scale up to millions of users and never have to worry about anything because it's done for you. It's really, really cool. It's a bit more advanced topic, so it's not something we're going to touch on, but if you're a programmer looking to do a bunch of these things, I'd highly recommend starting looking at Lambda. Again, it's really, really cool stuff. Okay, I'm going to talk about the free tier, and it's going to be relevant for the workshop part. And Amazon is fairly gracious in their free tier. If you've ever done the free tier for Azure, I think if I remember correctly, you get about a month with a certain amount of credits that you get, and you can do whatever you want for that credit in that month. Once that month is passed, you have to either find some credits somewhere else. I know there are a bunch of tools you can get them through, but yeah. AWS on the other, they have a different approach to things. They have what's known as the free tier. There's two parts of this, but there's a couple things. They offer a free tier that is for 1 year from when you create an account. So you can create an AWS account and get a bunch of free stuff to run in AWS for a year and never pay anything. There's also, on top of that, there's a tier that's known as always free. That includes Lambda. It includes a bunch of services actually, but there's a bunch of things here that you can get always for free. But honestly, the free tier itself is really cool. So we're going to start with EC2. EC2, again, it's a virtual machine that you spin up, right? Amazon gives you 750 hours of runtime per month for 1 year. It's of the instance type that's known as T3 micro or T2 micro. It's a fairly small instance. It's 1 CPU, 2 gigs of RAM, I think. But I'll say this from experience. I run multiple production workloads on T3 instances, T3 micro instances. And unless, again, you have a fairly significant amount of traffic, we're talking thousands of users, but if you're running Magento, if you're running a web store in Magento, sorry, T3 micro is not going to work. Magento is too demanding. But it's 750 hours, which is equivalent to 1 month of usage. And it's up to you how you want to divide this. If you want to run one instance for 750 hours or 1 month, that's fine. You can do that. They won't charge you for 1 year if you're on one instance. But if you want to test something, if you want to test auto scaling, for example, you can do that too. You can do 10 instances for 75 hours and not pay anything. Or you could do 75 instances for 1 hour. It's up to you. You have 750 hours per month, up to you. The same goes for RDS. It's not Aurora, it's RDS, but you can run a T3 micro RDS instance, meaning a database instance of MySQL or SQL Server, or I think even Oracle is free tier eligible, for a month, no cost. Or you can do, again, 10 instances for 75 hours, up to you. For S3, you get 5 gigabytes of storage per month for free. There are some other limits to S3 in addition to the storage. So if you're using S3, just be aware of them. If you're testing things, if it's just you testing things, it's more than enough. Don't worry about it. If you're using it for some sort of production or website load, just be aware that there are some other limits as well to data downloads and stuff like this. But for most people, it's more than enough. And finally, for Lambda, you get 1 million function requests per month for free. And this is not free tier. This is always free. I just deployed a workload to Lambda. We are running a cron function that does a fair bit of API design, or not API calls and inserts into databases and stuff like this. It's a fairly complex thing. We're running it every minute. And we started counting, and we're like, okay, yeah, we can run this cron function every minute for a month, forever, and never be close to the 1 million per month limit, and it's never going to cost us anything. In addition to that, like I said, Lambda charges for execution time, so how long your request takes to complete, or how long your function takes to complete, and you get 3 million minutes. 3 million seconds. So it's about it's equivalent that each one of your functions takes 3 seconds to complete. If you do less, obviously you have more. So that's the free. No, yeah, that's about the general overview of the free tier. Like I said, almost any AWS service is free tier eligible. You can look it up and you can use it for a year with no questions asked from Amazon. But look, if you go to AWS's website, there's this dedicated page to the free tier where you can see all the free for each service. So that's about the quick introduction to most AWS services. I think the easiest way to get to know AWS, honestly, is to try it out. And now, like, this is why I mentioned the free tier, because you can do a lot of things in AWS by creating an account and trying it out. It's not going to cost you anything at all. If you're very worried about being charged for AWS, I've spoken with the community or developer advocate for Amazon in the Nordics, and they've been very, very gracious to offer us a bunch of AWS credits. So I have a bunch of $25 credits that I can give you guys if you're worried about going over the free tier and not wanting to be charged for it. With that said, that's that's what I wanted to show you guys today. We have planned I've set aside time to do a workshop part now for the next about hour or so. At least I'm available for an hour. I'd be happy to answer any questions you guys have. All the workshop materials, like I mentioned before, is on GitHub. And I'm gonna go through some of the workshop things, or I'm gonna go through it and show it to you guys as well, if you want to see how we do some very simple things in part 1 here. I'm going to show you how to just create the Amazon account, launch an EC2 instance, and do some very basic things that you always do to any account that you set up with them. With that said, I think we're going to do just a 5-minute break so I can get something to drink. I'll be back in about 5 minutes. Let's see. All right, I'll be back in 5 minutes. Okay. Cool. It's been about 5 minutes, so we're gonna get started. So I posted the link in the Zoom chat to the GitHub repo if you want to do this on your own. It should, in theory, explain step by step exactly what you need to do. That's at least been the goal. So, but I'm going to go through it and demonstrate this. We're going to start by going to aws.amazon.com. And this is the front page of Amazon. We're going to go and create an AWS account. I have created an email and I'm going to generate a password. Oops. So you're going to need to choose a account name for the AWS account. It has to be unique, so it's up to you. I'm going to see if this is available. If not, we're going to have to do something else. It is. Cool. If you're doing this for a company, you need to mark it as professional. If you're doing this for yourself, just to try out things, mark it as personal. That just removes a bunch of the boxes for information for company information that you don't need anyway. Fill out a name, phone number, stuff like this. And we need to check that we agree with the customer agreement. Sure. Oh, right, I forgot this. You need to enter a credit card number to create the account. They will charge you $1 to verify that the credit card is working. Once that is done, they will refund the $1 to you. In the next couple steps, we'll go in and create a billing warning for you so that you'll get a notice if Amazon ever is going to charge you for anything. With everything I'm doing today, everything is within free tier. So it shouldn't, you shouldn't be charged for anything unless you're, you're spinning up things that are outside free tier limits. I'm going to show you how we terminate the instances and things like this. But I'm going to turn off screen sharing before I enter this. 1 second. Okay, let's see what this works. Yes, it worked. Cool. Share screen. Where did this go? Oh, there it is. All right, I'm just gonna move it. Sorry. All right, the next step is just a verification that you're actually a person. If I can read this. You can choose to get a text message or a voice call. Text messages are probably the quickest. You verify the code and continue. Now, you get a step here where it says select a support plan. Please, 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 please. If you're a company that's running production services on AWS, make sure you're paying the $100 for the business plan. You don't want to be on the basic plan in case something goes wrong. And I'll speak from experience here, especially if you're doing using new services. Amazon can, sometimes if you're doing very new services and things like this, they can be, they have had bugs here and there. We're testing out a new service for a customer that I know we've been dealing a lot with Amazon Web Services support. And I'll say this much, Amazon support is first class. If you dealt with Azure support, AWS is in a whole nother league. They're in different ball game. They're incredible compared to AWS. However, if you're just starting out, if you're trying out for yourself, do free, don't pay anything. If you're doing super basic developer and you're not doing any production workloads, do the developer plan. So you actually have access to their support team. Again, it's great. Wait, what? Okay, things disappear. Whatever, it doesn't matter. So that's it. Yeah, you select the free tier. If you're doing production, please do the actual professional support, because again, their support team is first class. You'll get some support things here. I'm not going to personalize my experience. I don't care much for that. And we can go sign in the console. I think I still have the password. Cool. Now, there are two different types of AWS accounts. There's a root account, and there's the IAM user. In most cases, you should never, ever use the root account. And we're going to go through a couple of those steps. That's a part of the workshop tools here, is that we're going to start locking things down. You want to use what's known as the IAM user. It's much safer, and the root account should, yeah, we'll go through it. But now that we only have one account, you need to use the account we just created with the email you just that you signed up with. Then enter the email and the password, log in, and we're in. Yeah, I'm actually going to save this here. Cool, we're in. Now, this is the front page of Amazon Web Services. I know some people say that it can be a bit confusing. I don't disagree. With that said, I prefer this over Azure, the user experience, but it's a thing, you get used to it. You find every service that they've ever created, all the 180 something services, it's available up here under services. You can, I search for everything. From EC2 is available here, S3 is available here, databases right here, or you can just type EC2 and it's right there. Once you start using these and you notice that you're using some services more than others, there's a pin here where you can pin certain tools. I typically pin EC2 to make it easy for myself, and the tool is always available up here. There's also on the left here, there's a history of what the tools you've been using most recently. So that's it. Okay, we've created an account. So we're gonna go to step 2. Like I said, if you're doing this on your own, I suggest reading through some of the materials here. There are some good reasons why you want to do this and why you want to change things. But the first thing you want to do, now that we have a account created, is we want to lock down the current user. We want to enable multi-factor authentication, because if someone ever gets a hold of your password to this root account, they can do everything, including delete the account, and you can't do anything to stop them. So locking and securing the root account is super important. So what you want to do is we want to go to services, and we want to search for IAM. It's identity access management, and it's how you control users and access to things. I'm going to open IAM. You get the IAM management console, and you'll see that you have what's known as the security status. Here, you want 5 green checkboxes. The first one is already checked, and that means that the root account that we already have do not have API access or API keys created. That's good. We want it this way. But we want to activate multi-factor authentication so that if someone gets a hold of the password for the root account, it doesn't really matter because we have the MFA available. We click on it, and we click on multi-factor authentication and activate MFA. There are 3 forms of MFA that you can use. You can use a virtual MFA device, which is the most common one. If you have Google Authenticator or LastPass Authenticator, personally, I use 1Password Authenticator. It doesn't matter. They're all available. Most virtual MFA devices work fine. If you have a YubiKey, hold on, I have one. 1 second. It's one of these things. It looks like a USB drive. You insert it into a USB port, and there's a button on top here, gold button that you press on. This is a hardware MFA device. Honestly, I don't use it too much. I find more efficient to use virtual ones. But again, if you're doing something for a production workload for a big company, I would use a hardware MFA device, and I would use one that is locked in a company safe deposit box or something like that. Because again, the root account is the only account that can delete the entire thing, and you don't want anyone doing that. So a hardware key for that. But in our case, because we're doing we're testing things, it doesn't matter using a virtual MFA device. Again, this works with most tools. You click show QR code. I'm going to pull up my own here, and I'm going to do, I just need to create it for myself. 1 second. If you've ever done this before, it's super easy. Launch Google Authenticator or LastPass or whatever. Click add to add a new one. You scan the QR code on the screen, and it does the rest of the work for you. All right. For myself, like I said, I'm using 1Password. I don't think you can see it, but it does it for me on the computer. Once it has been added, you need to add 2 consecutive codes. That means you need to wait. You get one code that appears, type that in, wait 30 seconds for it to refresh, and then you need to copy that code and type that in too. And it needs to be 2 consecutive codes for it to work. So it takes a minute. Mine is refreshing now. Okay, and you hit assign MFA. Cool. MFA is now enabled, and it's required when signing in. So we got another checkbox. Great. Now that we have that, we have MFA available. This is a huge step. It's shocking how many people don't do this, and it's really bad practice not to. So again, please do this. The next step is we want to create a user for myself. I don't want to use my root account, again, to not have it be compromised. So I'm going to create a user for myself. I'm going to type in a username. I want to give myself both programmatic access. That means I get access using the Amazon CLI or API. And I want access using the management console. The management console is the interface we're using right now, in case you didn't know. I need to create myself a password. 1 second. All right. Now we're going to generate a new password for myself. I'm going to copy that. I'm going to paste that in. I'm going to uncheck for myself. User must create a new password next check-in. If you're doing this for another user, if you're not doing this for yourself, I'd highly recommend just giving them a temporary, easy to remember password, and then checking that they must change it the next sign-in, or just auto-generate one for them. It's up to you. Cool. Next thing, we want to set some permissions to this user. Normally, when you do permissions, if you've ever dealt with Active Directory, you know that you don't want to assign permissions directly to a user. You want to do it to groups. In this case, I'm not going to bother because it's a test account, but normally you would want to create a group here too, the same way as you do in Active Directory. Assign permissions to that group, and assign your user rather, to the group. In this case, again, we're going to save some time. I'm going to attach a policy directly, and I'm going to check administrator access. And I'm also going to add one more. What is it? Billing? Yeah. I'm also going to add billing. This is, for some reason, Amazon, if you have administrator access, you don't necessarily have billing access. I don't know why they decided to do this. It's a role. It's frustrating. But those are the two boxes you need to check. Next, you're going to do tags. This is just a way to identify things. Every single thing you do in Amazon, or almost every single thing you do in Amazon, every resource you create can add tags. The reason why you want to add tags is that so that you can group things. You can group costs by tag. So if you have a project, if you have one project that is developing one product A, you can tag everything that is assigned to them with key. It's a key value pair, just a JSON key value pair. Put in a key, put in a value, and when you go into the billing console, you can filter by key, product, and value A, and every single thing that's been billed to that key pair will appear, and you can easily divide the cost of Amazon per your individual business unit or whatever you need, or project or something like that. It's also an easy way to find different types of users. You can put in a full name for someone if you want to do that. It's up to you how you want to utilize the tags. They have some examples. You can do job description, or you can do projects or whatever. Tags are super important. They're often overlooked, and I'll admit that I forget to do it sometimes when I'm doing this on my own projects, but please try and do it as much as you can, because it's really useful. Finally, we're going to review. It's just a summary of everything. We make sure we have administrator access and billing. I'm going to create the user. I'm going to download this CSV for myself. Here you'll see a summary of what you've done. We created the user. Here are the API access information. This includes the access key, and it includes the secret access key. It also includes a simple button for you to generate an email to send to that user. It opens up your email application. You can just hit send. It's super easy. Once that's done, you can click close. I'm gonna jump back to the dashboard here. I'm gonna do one more thing. Again, you want 5 checkboxes here. I'm gonna skip the 4th one because it's again the creating groups. It's not a big deal right now. But there's one thing I want to quickly do as well. When you're logging in as an IAM user, you need to know the account ID that you created. So in my case, it's BCUG. It's up here. It's shown up here. Or you can use a direct URL. That URL is by default some random account number. If you click here, you can change it and put an account alias if this works. Yeah, it's available. So if I want to log in with my new IAM user, I can access this URL directly. And I'm going to do that in a minute. I'm just going to assign the password policy first. But yeah, click the customize here to change that URL to make it life easier on yourself. Finally, I'm going to apply a password policy. And you click that and click the set button. This enforces a minimum password length. I would not have it at 6 characters. I would have it at 8 or 10 if I were you. Use a password manager, generate a random password to save yourself trouble. Check a bunch of boxes here that requires 1 uppercase. Yeah, definitely. Create 1 lowercase. Yeah, definitely. Require 1 number. Absolutely. Require 1 special character. Absolutely. Allow users to change their own password if you want. You can set a password expiration. If I were you, I would introduce the fact and force every user to use multi-factor authentication. In that case, set the password to expire after a year. That's a good number, but don't require people to change their password every month or every 20 days. If you have multi-factor enabled, it's not required. And there's a bunch of security research that backs this up. You can also prevent password reuse if you want to do that. In my case, I don't care for this user. Save the changes. You see now we have a password policy. That's it. Now, again, we're missing one checkbox in our dashboard. That's the user groups. Doesn't matter. But I'm going to log out. I'm going to log in. I'm going to copy this URL. And I'm going to log in with my identity user. Okay, so I'm going to copy and paste in the URL. Now that I'm logged out, you'll see that it redirects me a bunch of times, but it already has the account ID in here. So you don't have to worry about that. I saved this, didn't I? Yes, I did. Cool. So, sign in, and we're signed in with the user we just created. Again, oh, I forgot. I know what I forgot. Crap, whatever. I'm going to go back to IAM with this new user as well. And I'm going to do what I just did for the root user. I'm going to, actually not, sorry, my apologies. I'm going to click on users because we didn't do that last time. I'm going to click on users here to show all the users that are created. In my case, it's just one user right now. I'm going to click on myself, and you see a bunch of things. Here you see the policies that are attached directly to my user. If we had groups, they would appear here. Here are the tags. But what I'm after is the security credentials. Here you can change the password, console passwords. You can assign certificates. Here are the API keys that we just created. You can see that there's only the access key ID. There's no secret. You can't get that back. If you lost a secret access key, you need to generate a new one. There's also a couple other things here. If you want to use Amazon's GitHub alternative, you can generate SSH keys for that here. Honestly, I personally think code commit, which is, like I said, the alternative to GitHub, is too complicated. I don't see enough benefits to using code commit. And GitHub is any feature that Amazon supports that's a pull from code commit can pull in most cases from GitHub. So just use GitHub. It'll save yourself a lot of time and pain because dealing with code commit can be a frustrating thing. So yeah, their SSH keys, whatever. We're not going to worry about that. We're going to go to assigned MFA device, and we're going to go through the same thing we just did for a root user. Go to virtual MFA device, do that again. So that means that since you're creating a user for yourself, you'll end up with 2 MFA keys, and that is what you want. You want an MFA device, MFA for both of them. And you can do that here. You can also, in the same way, if you want to force, hold on, I just generate this for myself. If you want to force changes to other users, if you have access to IAM, if you have administrator access, you can do this to other users as well. You can force it for them. Let's see. PS. Okay, so I'm going to go back. I'm going to, here in a moment, virtual MFA device. I'm going to show the QR code. I'm going to scan it again, and I'm going to get a one-time key, and it's going to take another 30 seconds for me to get the second key. The one thing I forgot to do, I'm going to show you because it's super annoying if you don't do it, is I gave this user access to billing, right? I've added 2 permissions. I've added administrator access and I've added billing access. Unfortunately, because Amazon, for all its wisdom, have decided that even though I've gotten permissions to billing, I'm going to show you. You can go up here. You'll see that you can notice that you're on an IAM user by the username first and then the account ID. If I go down to my billing dashboard, or I could go to my account, same thing. You'll see that, oh, I don't have access to this, even though my permissions say that I do. So what is the alternative? Well, I'm gonna, actually I probably can't do that easily without showing. So we're gonna do like this, log back in. I'm gonna click here where it says sign in using root user email. because the only way to access the root user is through the email address of the root user. I'm going to go back in. I'm going to find the password. Oh, I've been sitting here quietly for too long, so the lights went up. Fantastic. Oh, there we go. I'm going to be asked for MFA code. Cool. That's correct. I'm going to go submit. Oh. Did I paste the wrong password? Probably did. I have saved the wrong password. Okay, is this one? Would be not great if I did this, but oh, I'm using the wrong key. Huh. Yeah, that was my typo. Yeah, wrong user and wrong password. Fantastic. There we go. All right, we're back in. Now we are on the root user. I'm going to go to my account. And this is not the user necessarily that I'm on. This is for the entire account. You'll see account ID, seller, doesn't matter, stuff. If we go down here, here you'll see I am user and role access to billing information. Okay. You have to click edit and click activate and update. And now you have access. It's stupidly hidden. Yeah. Now you know. You go again. We go back. I'm going to show you again. Click my account. You get on this page. You scroll down quite a bit. You say I am user and role access to billing information. With that access available, you can click on my billing dashboard and you'll get something like this. In most cases, you're going to see this. Since we haven't done anything yet, we don't have anything up here. It takes a couple hours for it to update. Okay, so that is step 2 of everything that's here. Step 3 is we're going to launch an EC2 instance. This is going to be, it's really simple. We're going to jump to EC2, which is the virtual machine software that Amazon provides. Okay, it looks complicated, I know. There's a lot of buttons. You don't have to worry too much about it, most of them. What you want to worry about is where it says running instances. You're only paying for running instances. Oh, haha. Right, I forgot about Zoom. So I think my laptop is about to crash. It's done this before. Yeah. All right, I'll be back in a couple minutes. I need to reboot the laptop. Sorry about that. Yeah, I'll be right back. All right, let's try this again. Yeah, unfortunately, Zoom has had a tendency to kernel panic my laptop, which is fun. Let's go back to Chrome. Here we go. All right, no big deal. Cool. And remember my session, lovely. GitHub. Cool. Yeah, we're gonna launch an EC2 instance. It's really simple. Again, you worry about the running instances here. That's really the only thing you need to be concerned about in terms of being charged for things. If it says 0, you're not being charged. Unlike some providers, I'm not sure about Azure and Google Cloud, actually how they do it, but I know some other smaller providers charge you if the instance is paused or stopped. Amazon does not. If it's stopped, it will remain in that state and you're not being charged for anything, which is good because that allows you to do some workloads. And I just put it on hold, and when you need to get started again, you can just hit play. So we're gonna get started. We're gonna click launch instance, and we're gonna be shown with all, we're gonna be get a list of all the different Amazon machine images or AMIs that are available. Like I said, there are a bunch of them here. A bunch of them are by Amazon themselves. You can see, yeah, these are the default ones. There's everything from Linux or different distribution of Linux to Windows Server. These are actual Windows servers with you can remote desktop to them. And also actually a tidbit here, you get 750 hours of Linux servers and 750 hours of Windows servers. So if you want to launch one Windows server and one Linux server, you can do that and run it per month, both of them per month if you want to. You can also create your own machine images. This is if you have a set of tools, for example, or a different software that you want installed on some sort of machine. You can install all of that, then take a snapshot and create an AMI of it. So you can launch a new virtual machine from that snapshot. Additionally, you can go to Marketplace. Like I said, here's a bunch of things you can pay for extra. OpenVPN has something here where you pay 10 cents an hour in addition to the EC2 costs. Splunk, you can run a Splunk Enterprise for log analysis. There are tons and tons of different tools you can run here. Infrastructure as code is kind of cool. Oh, yeah, Chef, obviously, right. You can run Chef servers in AWS. Yeah, and it's ready. Honestly, though, from a lot of us, what we want to do is just do a super simple Linux AMI. I'm a big fan of Amazon Linux because I'm a fan of Red Hat. But if you were more comfortable with Ubuntu, you can launch that too. I'm going to launch Amazon Linux though. You'll notice that this one says free tier eligible. That means that if you're launching this one, it's not going to cost you anything as long as you're within free tier. I'm going to go through a bunch of the instance steps details here, but you don't need to do this if you don't want to. You can spawn multiple instances if you want to do that. You can do spot instances. The current price, yeah, right, for spot is 0.03035. That's significantly lower than the current price for actually it's probably in here, come to think of it. Yeah, whatever, it doesn't matter. It's significantly lower than the on-demand prices. I haven't talked about these details yet. It's going to be in the next session if you want to learn more about it. These are the different networking tools, both subnets and the VPC, which is known as the virtual private cloud. This allows you to segment off different parts of your account so that one part can't necessarily talk to another. It works kind of like a firewall, stuff like this. But yeah, you can also choose which subnet. You can create subnets with different networking rules again, if you want to do that. You can either create one, or I'm just going to launch it in the default one. It doesn't matter for my case. You can disable a public IP. What this means is that if I go here and disable, this instance is not going to have a public IP address, and it's not going to be possible to reach this instance from the internet directly. If I want to access this instance from my machine, I would need another way in, either through VPN, or you can create a Bastion host or a jump box or SSH box. It's another server that you launch in your subnet that you SSH to, and you SSH from that box to this one that we're creating now. By default, public IPs are enabled, but just because the public IP is enabled does not mean that this instance is available, just so that's said. There are other networking rules. We will get to that in the security group here in a couple of steps. That you can say that you can block access to this even if it has a public IP. You do not, when you use these auto-assigned IPs, you do not pay for them. So there isn't really a downside to assigning one, to be fair. I'm going to skip placement groups. It doesn't. It's a more deeper subject. Same capacitor reservation. You can create an Active Directory in AWS. It isn't as good as Azure AD. I'll be honest. Azure AD is very good, and it's very, very, very easy to integrate Azure AD and AWS. I think that's a subject we're going to cover at a later point, just because it's so powerful, and a lot of companies do it. Even those companies that are 100% in Amazon, they do run all their workloads in Amazon, typically use Azure AD for authentication because it's so powerful and it's so easy to integrate. IAM roles is also a deeper security subject, but the point is that you do not want, let's say this server wants to access a database. For security reasons, you really don't want the passwords and everything stored on the server, but you can give it access using rules and secret manager. It's a very deep subject. It's very interesting, and I'd recommend looking into it. But it's one of the big concepts around security, that you assign roles, you don't assign passwords to instances. We can do a couple more things here. You can decide when you hit shutdown. What do? Do you stop it or do you terminate it? You can enable termination protection. That's just an extra step. For production workloads, this could be very good to do. It's another step when you hit terminate for an instance, so you don't accidentally delete something. Monitoring, don't worry about it. It's detailed monitoring, don't worry. Tenancy is how you can decide how your instance is placed. For free tier, you need to make sure it's shared. But if you, for legal reasons or licensing reasons, cannot share a physical host with others, you need to check one of these. It's either a dedicated host or a dedicated instance. If you need that, you need to look into it and really look into it, but it's available. Elastic interference, don't worry about it. Don't worry, it's fine. Credit specification, that's actually changed. It used to be called T2 or T3 burst. It's a more advanced subject too, but it allows your instance to burst and use more CPU than 100% in certain case, or in a limited amount of time. So you can check that if you want. File systems, don't worry about it. Metadata, don't worry about it, it's fine. This one, on the other hand, though, is cool. User data is you can input bash scripts here. This is especially useful if you're doing auto scaling. You can put in a bash script here, or Python script for that matter, actually. And that will run as soon as the instance is started. So in theory, you could do something like this and do yum update, yes. And now as soon as the instance is launched, actually, did I do it the wrong way? Whatever. And if it fails, it fails, it doesn't matter. Yeah, it will run yum and update. You can, the same way you can, actually, let's do that too. Let's update it first, then do yum install httpd, which is Apache. And then we can do systemctl enable httpd and systemctl start httpd. Now in theory, it should install. Actually, we need a yes. It should install Apache and run it as soon as the instance is spun up. And obviously, you could do more advanced things in this. Here's storage. Storage is a different topic, not for today. It's going to launch by default with 8 gigabytes. You can see the amount of IOPS it gets. It's fair enough for a small instance. You can select different types. If you need a very, very fast drive, you need provisioned IOPS for SSDs, but you can also use magnetic storage. You cannot use magnetic storage for root volumes though, or where you've installed an operating system. You can also choose to encrypt it if you want to do that. I'm not going to do that because it takes time. Again, tags the same way as on users. You can tag it to projects or whatever you want. Now, the final one here is security groups. And this is where things get interesting. This is how you define what has access to this instance. And we're talking both from the internet and from other AWS resources. In this way, you can, right now it says SSH, right? It's a source 0.0.0.0/0. This means that this instance right now will have SSH access from anywhere, but it will not have HTTP access. So Apache will not work. It will not be an open web server, and we're going to launch like that, and we'll change it in a second. If I want to restrict this, I can put in my own IP. I can put in a IP range if I want to do that. I can go in and set specific ports, because right now I can't even ping this instance. ICMP is blocked by default. But you can put in anything, or you can just say, okay, all TCP is fine, but I will only allow it from this IP, or you can specify another security group. So if you want to allow all TCP traffic from the database, you can do that. But specify only the security group ID of the database, not necessarily IP, because the IP can change, but if you specify the name of it or the identifier of the database, it will allow that. So we're going to review and launch. It says improve instance security, it's open to the world. Yeah, we know that. I've opened SSH to everything. That's fine. I'm going to click launch. And now, since this is a Linux instance, this is different for Windows. If you launch Windows instances, you will get a remote desktop file. But for Linux instances, Amazon do not operate with passwords for instances. It's not secure. So the way they do it is that they operate with SSH keys. If you haven't used an SSH key before, I'm going to create one and download it and show you. If you have one, you can upload it. You can use your own. I'm just going to create one for this. Cam test. I'm going to download the key pair. I get a PEM file in return. I'm going to launch instance. If you lose this PEM file, you're kind of screwed. It's as simple as that. I think there are ways to go around it and actually solve it. But honestly, if you've done this, if you lost it, it's easier to just launch another instance, to be honest. I'm going to go back to the EC2 instance dashboard. It says pending. It will take a couple minutes for it to launch. You see that we already have a couple things. Oh, actually, I forgot to mention something. I noticed because of the IP. It's going to launch whatever. I'm going to show you in a moment. The thing I realized is that we're currently launching this in the US East 2 availability zone because I forgot to show that in the beginning. Up here, it says Ohio, which is the US East 2 region. If you want to launch anything in somewhere else, you need to make sure you change the region first. I'm not going to right now because it will require me to redo all the EC2 and the key pairs and stuff. So I'm not going to. If you want to try stuff out, I'd recommend using Ireland, US or EU West 1 for us. Stockholm is very, very fast, but it does not have all the features yet. It has, obviously, it has EC2 and database and all kinds of things. But if you go into a little more depth, Stockholm is missing quite a few features so far because it's a new region that launched last year. London is just expensive, so don't use London unless you really have to. We use Ireland for a lot of production workloads for a lot of customers. It's not a big deal. That it's just a bit further away. Frankfurt has its own thing because it's Germany, and Germany has privacy laws and stuff. So yes, you can use it, but honestly, it's just as easy to just use Ireland. But right, yeah. So right now I'm in Ohio. It doesn't matter. It's just going to take just a couple more milliseconds to launch this. Okay, I'm going to actually switch screen sharing to my entire screen, and I'm sorry, it's a very large widescreen, so it's going to probably be a bit hard to see, but it makes it easier. But I'm going to make it bigger. Okay, sorry about that. Okay, I'm in my command line, and I have this here. I'm going to show you the this way because it's a quick way to show it. If you hit connect, it will show you what you need to do. The first thing we need to do is I need to locate where the file that I just downloaded is. It's in my downloads folder. And the first thing we need to do is we need to change permissions for this file. The default permissions won't work when you're doing SSH. I need to see how chmod it, and I need to do it to 400. And the file was called kmtest. Cool, now we're good. Now we're going to connect using its public DNS, and I want to specify that I'm going to use the new key, and it says exactly here what you're going to do. The flag you want to do for SSH is use -I and then specify the name of it. When you're using Amazon Linux, the username you want to do or want to use is EC2 user by default. I think Ubuntu is admin, but if you just hit connect, it'll show you exactly here what the username and everything is. So just copy and paste it, it's fine if you're in the correct folder. It's SSH, it is SSH, so you need to accept it, and we're in. So if I actually do systemctl status httpd, did that actually work? It didn't start, okay. Interesting. Did it even install? Ah. Okay, whatever. I'm not going to spend time on this now. It doesn't work. Yes, it didn't work, so whatever. Not a big deal. I'm not going to debug Linux. Now, if it was working and if we were able to access it, because we haven't changed the firewall for a better word, for lack of a better word, it won't. You can't connect via HTTP, so we need to change that. If we go to security groups down here, it says launch wizard 1 because that's what I named that security group by default. You'll see, okay, security group ID, great, VPC, lots of stuff. If we drag up from the bottom here, you'll see inbound rules. These are the ones that we just set. Hit edit, and we're back to the interface where we opened up everything. If we go to add rule and add HTTP, we set it to 0 or /0, which is open to the world. Hit save rules. the security group updates instantly. It's not like it takes 5 minutes. Nope, it happens instantaneously. So if this actually was working properly, we could access Apache at this point. Yeah, that is about it for launching an EC2 instance. Now we want to clean it up to make sure you don't get billed for anything. Come on, go away soon. I don't need you. To do that, I'm going to go back to EC2. I'm going to see, you now see that it says running instances 1. I'm going to go to actions, instance state, and I'm going to click terminate. It says, yep. It's going to also, the warning here is that it's also going to delete the storage, the drive that was connected. Yep, that's fine. We're going to click terminate. You'll see that the SSH connection was terminated, and the instance will be shutting down within a couple minutes. It actually takes a fair bit amount of time before it's actually terminated. Yeah, so that's EC2. It's shutting down. The other quick thing I want to show you is RDS, which is MySQL, or sorry, relational databases, but we're going to launch a MySQL database. Again, it's very, very simple. You go to RDS, type manage relational database service, which is the one I have in the background here actually. And you see that you have, by default, you have some limits. You can only launch 40 database instances. If you need more, most limits in Amazon are soft limits. So you can just literally ask them and send the support ticket. They answer within 12 hours and they increase it. I'm going to click create database, and it asks us a bunch of things. Now I'm going to do easy create because that's simple enough. I'm going to do MySQL. I'm not going to do Aurora because, oh, hello. I'm not going to do Aurora because, again, it's not free tier eligible because it launches in multiple availability zones. It launches multiple instances. I'm going to do MySQL. I'm going to do the free tier, which is, again, it's a T2 micro instance. It's not a very big one, 1 CPU, 1 gig of RAM, 20 gigs of storage, but it's cheap. It has a username and password. I'm going to auto-generate this, and it has a bunch of default settings here. Default settings are typically fine when you're doing testing in free tier. It sets it in its separate subnet. It creates a separate security group so you can manage access to it. It says publicly accessible to no. This means that you cannot, from your laptop, directly access it. You need a jump box like I talked about. If you want it publicly accessible, you need to actually go away from the easy create and do standard. You can change these settings. And then you can set it to publicly accessible and then IP restrict things. But by default, it's not available. We have some other things, monitoring enabled, sure. It does minor version upgrades of MySQL. That means we're by default on 8.0. It'll do minor versions of 8.0.1 to 2.3, whatever. It'll do those updates for you. And delete protection is not available. A bunch of these you can change afterwards anyway, so it's not a big deal. I'm going to click create. It's going to work for a couple minutes, and all of a sudden you have a MySQL database. And it's super easy. It's almost instantly available, and you no longer need a database administrator to do this for you. Again, just talking about some limits and things like this. Again, I have been working on a couple projects where we've been using, we reached a couple limits for, Amazon has a SMTP service if you want to do email from a website. You can use Amazon's own SMTP server. It's super simple to set up, but the default rates are fairly low. I think it's just a couple hundred emails per day. So we asked them to up the limit and asked, okay, can we send about 1,000 emails per day? And they said, yeah, sure, we can upgrade it. And they set us to 50,000 emails per day. So the limits are typically fairly soft, and as long as you have a good reason for going over it, it's not a problem. They just have it there by default, so your costs don't run amok the first time you're doing things. And trust me, a lot of people have left something running by accident. Again, Amazon support team is very, very great. Like they're again first class, and I know of multiple companies and multiple people that have racked up literally tens of thousands of dollars in Amazon bills by accident because they left some instance running or something that generated a lot of costs for them. They've contacted Amazon support saying, help, we really screwed this up. It was an accident. It's not going to happen again. And they have credited them almost the entire bill. So if you talk to them, they're very good about that. While this is creating, it's not a big deal, and we're talking about billing. I'm going to go into billing dashboard quickly. I'm going to show you just one thing that's really, really, really useful, and that's AWS budgets. It's down here by default. You can create and manage your budgets, and you can say, oh, I want a cost budget. Okay, monthly budget doesn't really matter what you call it, but you can set a recurring one and say that I want a budget of $5 per month. Actually, I need to call it something. Configure an alert and say that once I reach 80% of those $5, I want an email. Add an email contact. You can do multiple things. You can notify via Slack if you want to, using the AWS chatbot. But create a budget, hit create. Now I'll get an email from Amazon when I reach $4. And this is something anyone should do, especially when you're testing things out. This allows you to get a heads up if your budget, if you leave something running. If you don't have anything running, that's fine. But it's an alert to to get a heads up and avoid getting really charged a lot. Yeah, now that we have things running and we have a budget alert, you can set multiple ones. So if you expect that you get some cost, you set some. Yeah, there's a lot of options here. Sorry, 1 second. Just gonna check if the RDS is up so I can show you that and terminate it if needed. Still doing stuff. While we're in here, it's almost ready, but now it's doing the initial backup and stuff, so cool. You'll see here's the endpoint. This is the one you want to point your application to. It has ports. It says the availability zones, security groups, default groups, and also says here publicly accessible no. Because it's not ready, I can't change it yet, but you can go in and change that too. You can go in and see that, okay, this is a replication. You can set it, since it's MySQL, and select replication destinations, things like this. You can have proxies. There's a lot of different options, like you would in any other MySQL instance, but this is just quickly and easily available. If you want to delete it, that's here. You can create read replicas if you ever dealt with that. It's a great way to easily spread out the read loads from the database to speed up things. Direct your read request to a replica instead of a primary source. Things like this. We'll refresh it and see if it works. The same way you can with normal EC2 instances, you can also have reserved instances of RDS. It's not that common. It's if you have very high workloads, you might want to reserve the capacity, but it's not very common. Here are also the default security rules saying that this one allows traffic from anywhere, basically. No, sorry, my apologies. It allows traffic outbound to anywhere, but it does not allow any traffic except for traffic from this group, sorry, which is in this case in itself. All right, stick to it, whatever. The only thing I wanted to show that was that you can change the public availability of it, but it doesn't matter. Databases can be backed up. Like it does say here by default, it's currently backing up. You can also export these backups to S3. So you can back up the database, export it to S3 so you know it's safe, and then you can restore the database from a S3 snapshot later. By default, the database backs up every 24 hours. It takes a snapshot every 24 hours. There's incremental snapshots, if I remember correctly, and you do not pay for the storage of those incremental backups. But you can also take manual ones if you want to. It's maintenance and backups. Yeah, maintenance and backups. You'll see that here's the initial snapshot it's created and stuff like this. Yeah. That was about it. What I was going to cover today. It shows you in the GitHub what's it called? Repository, in the workshop repository. Sorry. There's a bit more detail about everything, and it shows you basically exactly what I've shown so far. It also shows how you can connect RDS to the EC2 instance. So the EC2 instance only can talk to RDS is in here. And yeah, it shows you how to connect and things like this. But that is what I had planned for today. If you guys have any questions, I'd be happy to answer any. Yeah, that was what my plan was for today. All this thing is loading. Oh, now it's available. Great. Yeah, you can click modify up here. And you can change a bunch of the settings that was set by default. You can even change storage types while it's running. It's cool. You can change the master password and change publicly accessible. So if you change this, it will now create a public IP. So that's it's available. It still will not be available until you, it will still not be publicly available until you open up the security group. So it wouldn't be available to the entire world. It would only be available to those that are available in the security group. You can also, these options aren't shown by default when you're creating the instance. You can use your IAM user that we just created. You can use that for authentication instead of the master password. You can use those users and roles, which is really efficient. It's a much safer way than handing out the master password to everyone. Here's a bunch of other small things. You can set them, a bunch of things. But yeah. Oh, I closed the chat. Oops. Let's see. Oh, there you go. Thank you, both Sunil and Tom-Stian. Thank you for attending. Like I said, if you guys, I forgot to say that earlier. Like I said, I have a couple of $25 Amazon credits that I'm not going to use for anything. So if you guys want them, I'd be happy to share a couple of them. Hold up. So to you guys that are still here, I'm going to do like this. And I'm going to do, I'm just PMing you guys in the chat. I have no idea what it looks like to you guys, but these are AWS. Like I said, they're $25, so it allows you to test some things. I'm gonna show you quickly how to redeem them. If you go into billing dashboard, like this, and you go to credits, you can click redeem credit, promotion code, 5, whatever, it doesn't matter. I'm not gonna redeem and waste one. But yeah, you enter that, hit redeem credit, and you get $25 that you can use for whatever. I'm not sure, actually, I haven't tested them, so I'm not sure how long they're valid, but from experience dealing with the AWS credits, they're probably a year, I think. Probably a bit more. Let's see. Let me test on an account that I actually can try on. Hold on.
Looks like it's over a year, so it's, yeah.
Oh, nice. That's really cool. Yeah, the longer we can use it, the better. They're not available for all. That's a good point, actually. Come think of it. They're not available for all services. You cannot, in the most part, you cannot use them for example, you can not use them towards reserved instances. You cannot use them to pay for domains, something like this. There are restrictions. So that once you have redeemed them, on the right side, it will say applicable products. Click that button and you'll see what services are applicable for the credits. Most things in here are, but like I said, there are some things like reserved instances and paying for domains that won't be, you can't use it. But other than that, most normal things like EC2 instances, you can, if you want, you can spin up the, actually I'm logged into a different account here now, but in theory, if you want to go nuts, you can go in here and go launch instance. And go down this list and see the ones where you have 64 gigs, 64 CPU cores, 256 gigs of RAM and stuff like that. There are a bunch of other too. There's a bunch of NVIDIA GPU instances too that are really cool. That will cost you $25 per minute or per hour. So if you want to waste it really quickly, that's the way to do it. But yeah, it's fun. But again, thank you very much for attending, everyone. If you have questions, feel free to reach out. We've created a Slack community where you can reach me as well. The link is in the GitHub repo, I think. It's on the front. Yeah, it's in one of them. Yeah, I try to organize it, but it's in, yeah, it's in the about here, and there's a URL here, directly to the Slack community if you guys have questions. Fantastic. It's yeah, it's good that people appreciated it. Like I said, we plan on doing this again. Some of the work has already been done. You can see again, and actually I haven't updated. I haven't updated the repo. They're still local. Okay, whatever. I was about to say the work is coming here. I'll push it to Git, where all the rest of the things will appear after a while. With what we're talking about next. But yeah, the plan is to do one probably per month if time permits. Yeah. So again, if you have questions, reach out. I'm available Slack or add me on LinkedIn and ask me there. I'll accept pretty much anyone on LinkedIn these days. Yeah, and I hope to see you again at a later point. I'll stop sharing and I'm going to stop the recording.